All right, good day, viewers. You're highly welcome to this class. So today we'll be talking about the inverse of Laplace transform. So, of my previous videos, we've talked about the general introduction to Laplace transform, then the derivations of the functions under Laplace. So, all right, today we'll be talking about what's it called, the inverse, as well as how do you use Laplace inverse to solve differential equations. Yeah, so we'll be looking at that. So after Laplace transform, we'll be looking at how do you use Laplace transform to solve, because if you understand Laplace transforms, the inverse of Laplace transforms, and you don't know how to use it to solve differential equation, like to some extent you have not uh, gone far or do well on what you're supposed to do. So now today we'll be talking about inverse of Laplace. So in my next video, we'll be talking of how to use it to solve differential equations. Now, we know the meaning of inverse from our basic mathematics. That let's say you have a function. Let's say you have a function y equals to 3x plus 2, and they ask you to find y inverse. You know that y inverse is just what? It's just be 1 over y. Y inverse is the same thing as what? The same thing as 1 over y, right? So 1 over y, it means you are taking a reciprocal of this, which is going to be what? 1 over 3x plus 2. That's just your y inverse on a neutral ground, on a normal basis. You understand? But when we're now talking about the inverse of Laplace, so you have to understand and know all the Laplace functions that we have done before. You get, because if I say what's Laplace of k, which is constant, you say k over s. It means if I ask you what is Laplace inverse of k over s, you said what? You said k. That's the meaning. So just like the opposites. So all the Laplace functions that I have known, so taking the opposites back to the function itself is what we know as what? Laplace inverse. So you know that all your Laplace functions are always being in what? In Laplace domain, which is s. They always be in Laplace domain. But for Laplace inverse, it will go back to the time domain, which is in terms of t. You get. So let's see some questions uh before we now move further on this Laplace inverse, because it is very important for you as a student to know the partial fractions, because anytime you're solving Laplace inverse and you don't understand what we mean by what we mean by Laplace inverse, or what we mean by partial fraction, sorry. So we are talking about partial fractions here, and you don't understand it very well, so it's going to be a problem. So they might be giving you some little Laplace inverse that we have already done in normal what's it called, normal functions that we have derived. They might be giving you that you just check the functions and try to answer that right, but not every time. In some cases they will give you in such a way that you have to solve using what? Using partial fractions to split the functions, so that before you can now use the main Laplace table. You understand? Now let's see some questions. Number one. Number one. The question says find the Laplace inverse of the following. Laplace inverse of the following. Number one. Find the Laplace inverse of the following. A, you have L inverse of 1 over s minus 2. B, L inverse Laplace inverse of 4 over S C L inverse of S over S squared plus 225. That's for D. L inverse Laplace inverse of 12 over what? S squared minus 9. Then let me see one more. E Laplace inverse of right Laplace inverse of 1 over, we have 1 over 2s minus 3. Now let's see the solution. Number 1, A, we have Laplace inverse of 1 over s minus 2. You could recall that when you have the function which is exponent, if you go back to the Laplace table, you could recall that when you have the function which is exponential at or exponential kt, as the case may be. Some people might use a, some people might use k. It's the same thing as what? The Laplace will be what? 1 over s minus a, right? 1 over s minus a. That's the Laplace. So it means that the Laplace inverse, the Laplace of exponential at is equals to what? 1 over s minus a. Therefore, you can conclude that the Laplace inverse of 1 over s minus a is equals to what? Exponential at. So it's just opposite. Now look at this. Your a here is like what? A is like what? Minus 2. A is what? A is like 2. Sorry. A is like 2. Right? So you put it there. So therefore, you're going to be having the Laplace inverse to be what? Laplace inverse of 1 over s minus 2 to be equals to what? Exponential. What's our a? 2. Exponential 2t. So that's the Laplace inverse of that. You can see how easy it is. B, you have exponential Laplace inverse of 4 over s. You could recall that the Laplace of what? Of k, where k is what? Constant. A constant can be any number, 1, 2, 3, 4, 5, anything. So the Laplace of k is the same thing as what? The same thing as k over s. So therefore, I can conclude that Laplace. Therefore, I can conclude that Laplace inverse of k over s is equals to what? Is equals to k. You get? So it's just simple mathematics. So because normally Let's say I want to do a mathematics here. Let's say okay, I have Laplace of k is equals to k over s, and I want to make k subject of formula. Divide both sides by Laplace. Abi? So I'm going to be having k equals to k over s over Laplace. Abi? Because I've divided through by Laplace. So now this Laplace is same thing as what? K equals to 1 over Laplace into k over s. Is it not the same thing? Same thing. So 1 over Laplace is same thing as what? 1 over Laplace is same thing as Laplace inverse of k over s. So Laplace inverse of k over s is what? K. That's just normal mathematics that you have to know. But from the generality, you can still say okay, if Laplace of k is equal to k over s, definitely Laplace inverse of k over s will give us k back. That's the meaning. So now put it here. So therefore the Laplace inverse of 4 over s will be equals to what? Equals to 4. Equals to 4. That's all. Then the third one. The third one. The third one which is the Laplace inverse so the Laplace inverse of what? Of s over s square plus 25. Abi? You could recall that the Laplace recall that the Laplace of s over s square plus a square is equals to what? Cos at. Cos at. Cos at. So if Laplace of this thing resemble, of course, this value like this, you can write it as the same thing as the Laplace of what? S over s square plus 5 square. Is it not the same thing? Plus 5 square. So because 25 is 5 square, right? So now to now be what? Your a is like what? It's like 5. You understand? So therefore the Laplace inverse of what? S over s square plus 25, which is the same thing as the Laplace inverse of s over s square plus 5 square. Everything will be equals to cos 5t. That's it. Then the next one is Laplace inverse of what? Laplace inverse of 12 divided by s square minus 9. Laplace inverse of s square minus 9. So this is same thing as what? You can recall that the Laplace from the Laplace table, if you have not forgotten, you can recall that the Laplace of, when you have the function, so here I said Laplace of s over s square plus a square, it should be Laplace inverse. Yeah, because Laplace of cos at is s over s square plus a square, right? So now from this place, you could recall that the Laplace of, because we are having s square minus 9, and 9 can still be 3 square, right? So when you're having the Laplace of a over what? Sine hat, yeah, you could recall from your parabolic Laplace that the Laplace of sine hat is the same thing as a over s square minus a square. Now, which shows that for sine at, what you're having here, a and a are the same thing. So, but if you look at this place, you're having 12, you're having what? You're having 9. They are not the same. So that means, let's try the Laplace of what? Of, let's try the Laplace of cos. The Laplace of cos hat is the same thing as what? S over s square minus what? Minus a square. That's for cos hat. Now look at the same thing what you have there. You can see that s over what? S square minus a square. And what you're having here is 12, not s, right? Is 12, not s. Now, how do you make it to be the same thing? That's where you're going to do something. So how do you make it? Okay, let's see something. From this place, I'm having between two functions, right? You know this 12. 12 is the same thing as what? So I can have it as Laplace inverse of, open bracket, 12 is the same thing as 4 times 3, right? Over s square minus 9 square is the same thing as 3 square, right? So I can bring the 4 out, right? So it will be 4 Laplace inverse of 3 over s square minus 3 square. So 3 over s square minus 3 square, it has resembled sine what? Sine hat. So therefore, finally, you can have 4 sine h 3t. That's the answer. Then I think we have the last one. So the last one, you can try it on your own. So let's now see, these are the basic simplest one. Let's see other ones. That always require you to use partial fraction. Yeah. So let's see example 1. Example 1. Decide, determine the Laplace inverse. Determine the Laplace inverse. Determine the Laplace inverse of L inverse into 5s plus 1 over what? Over s square minus x minus 12 over s square minus s minus 12. Now if you look at this question very well, you observe that there's nowhere in your Laplace table that you can find this direct. You cannot find this direct. There's no Laplace of 5s plus 1 over something that will give you something. There's no Laplace of that. So therefore you have to simplify this one before you can get the Laplace what? Inverse. That's the meaning. So now, how do you get the Laplace inverse? It's very simple. So just resolve that. Since you know that, okay, you have a fraction, and you know that for you to simplify further, there's nothing you can do than to solve what? To solve using partial fraction. I think okay, let's see what we have at the denominator. The same thing as Laplace inverse of 5s plus 1 over, if I factorize this, I'm going to have this s square minus s minus 12. So two numbers that when I multiply, I'm going to have 12 minus 12, and when I add, I'm going to have minus 1. So that should be open bracket s minus 4 and s plus 3, because if you say minus 4 times plus 3, you have minus 12, and minus 4 plus 3, you have minus 1. All right, so you factorize. I think as you factorize out, there's a particular term or a particular bracket that will cancel this numerator. You can cancel, like this cancel this, so you cancel first. But as you factorize this one, there's no number that actually works, that actually divide. So what you do is what is you continue. You get so how do you continue? You now resolve into partial fraction. That's what you do. So how do you resolve? Bring that one, 5s plus 1 over s minus 4 into s plus 3, everything equals to, so you can say this is s minus 4s plus 3. So the knowledge of partial fraction is not something that can be taught here. You get, so it is expected that you have known it, but you can watch out for my subsequent videos on that. I will do videos on partial fractions. So you can say a over s minus 4 plus b over s plus 3. So that's the rule, since you're having it factorized. So that's what you do. So from this place, you now find the what? You find the LCM. So watch out for the continuation of the solution in the next video.